Hello everyone, welcome to oneQuestion. Let's take a look at this question today. There is a disc of mass 10 grams. It is kept floating in air by throwing some marbles at it from the bottom. Now the rate at which these marbles are thrown is 10 marbles per second. The mass of each marble is 5 grams and all these marbles impact at an angle of 90 degree to the disc. Now we have to find the velocity of these marbles so that the disc remains floating in air. Now initially the marbles are traveling with a velocity v in the upward direction, and after the impact they are traveling with the same velocity v in the downward direction. So there is a change in momentum of marbles taking place over here, which is then exerting a force on the disc. So let's calculate the change in momentum of the marbles. So the initial momentum will be mass of the marble into velocity, which is m times v, into number of marbles impacting per second, which is 10. And let's assume the upward direction to be positive and the downward direction to be negative. So initially the marbles are going upward, so the momentum is positive, that is 10 mv. Let's calculate the final momentum. That will also be mass into velocity, which is m times v, times the number of marbles, which is 10. But finally the marbles are going in the downward direction, so the momentum will be minus 10 mv. Now let's calculate the change in momentum, delta p, which is equal to final momentum minus 10 mv minus the initial momentum, which is also 10 mv. So the change in momentum is minus 20 mv. Now due to this change in momentum of the marbles, a force is exerted on the marbles in the downward direction. But according to Newton's third law, an equal and opposite force will be exerted on the disc in the upward direction, which balances its weight, and hence the disc remains floating in air. So let's calculate the force exerted on the marbles. So as we know, force is nothing but rate of change of momentum. So the average force exerted will be delta p over delta t, where delta p is the change in momentum of the marbles, which we just calculated over here, and delta t is the time in which this change in momentum takes place, which is 1 second given to us over here, as it is given that the rate of marbles colliding with the disc is 10 marbles per second. So the force exerted will be minus 20 mv upon time, which is 1 second, which is minus 20 mv. So force of minus 20 mv acts on the marbles in downward direction, and according to Newton's third law, an equal and opposite force acts on the disc in the upward direction. So let us draw the FBD of this disc. So this is the disc. Its weight is acting in the downward direction, mg, and a force is acting on it in the upward direction due to the marbles, which is minus 20 mv. Now since we have already given the direction of this force, let us remove the minus sign. And now let's balance these two forces so that we can calculate the velocity of each marble. So mg equals to 20 mv, where m over here is the mass of the disc and m over here is the mass of the marble. Let's substitute the values in this equation. We get mass of the disc, which is 10 grams, into g, which is 10 as mentioned in the question. This is equal to 20 times mass of the marble, which is 5 grams, into velocity of each marbles. Now on solving this equation, we get velocity is 1 meters per second, which is the correct answer of this question.